All right, welcome to chapter 8. So this lesson is going to be an introduction to chapter 8, which is sampling and sampling distributions. And although this is an intro, I really can't stress enough how important section 8.1 is, because we've been talking about this concept, which I'm going to talk about in a minute, really since the beginning of the semester, since chapter 1. And the concept is that populations are generally either quite large or have an unlimited number of data values or is partly unobtainable. And since a population can rarely be studied completely, which we've been saying since chapter 1, right? We have to take a simple random sample. So we use a sample randomly selected from the population, and we're going to use that as a convenient and economical procedure to estimate the characteristics of a population. So we said that realistically, we're not going to be able to get the information from an entire population or to study an entire population. But what we can do is we can take a sample from that population and start looking at the characteristics of the sample. And we're going to be able to use the information from the sample to start drawing conclusions about the population. But in this section, we're going to focus on how we can use sample information to estimate characteristics of a population, specifically the mean. So we might be interested in calculating the population mean, but we don't have information from the entire population. So what we do is we could use sample data and take the mean of a sample. But the mean of the sample, which is X bar, is probably not going to be equal to the mean of the population. Actually, if we were to keep taking samples of the same sample size from the same population, it's very likely that none of these sample means, none of these X bars would be exactly equal to the mean of the population, which is mu. So there's only one true value for the mean of a population for mu. But there's many different sample means that we can get depending on what sample we grab, because remember, samples are random. So whenever we use a sample to calculate the sample mean and use the sample mean as an estimate of mu, most likely they're not going to be the same and there's going to be a difference. And we call this difference a sampling error. So sampling error is the difference between the value of a sample statistic, such as X bar, the sample mean, and the true value of the population parameter, which is mu. So if we take the difference between the two values, we get what's called the sampling error. So the sampling error is equal to the sample mean minus the population mean. And this is very realistic that most of the time we're going to be using sample information to estimate characteristics about the population, such as X bar, right? So we could use X bar as an estimate of mu, but most likely they're not going to be the same and there's going to be some sort of sampling error. So let's do an example. I want to show you an example of what I mean. So let's look at example 1. It says, suppose a population of 8 students has the following ages: 19, 23, 21, 26, 19, 23, 24, and 25. I want you to calculate the population mean. So if you want to pause here and get the mean of that population, do so right now. And I'm going to do it also. And I got 22.5. So you guys should have gotten 22.5 years old. So that's the mean age of this population. So now what I want to do is I want to illustrate the idea that I was talking about at the beginning of this lesson, that most likely in real life, we're going to have to estimate the population mean. And we're going to do so by taking a sample, and then we're going to calculate the sample mean and use that as an estimate. But there's also going to be sampling error involved. So what I want you to do is, and you can pause here after I explain what to do, and then I'll calculate my sample mean as well. So what we're going to do is we're going to take a random sample of 3 students of your choice. So pick any 3 student ages from above. I want you to calculate the sample mean, and then I want you to tell me what the sampling error is. And I want you to do it on your own, and I'll do mine on my own because I want you to see it's fine if we pick different samples. We're probably going to have different sampling errors, which is fine. That's kind of my point. So pause for a minute, pick 3 of the above ages because we're going to take samples of size 3 or 1 sample of size 3. And we're going to calculate the sample mean, and then we're going to calculate the sampling error. So you can pause, and I'll give you a minute. So I chose the sample 23, 24, 25 from above. Now my sample mean, X bar, so if I add up those 3 values and divide by 3, right, that's how we get the sample mean, I get 24. If you picked a different sample, that's great. You're going to get a different sample mean. Now, what's the sampling error? So remember, the sampling error is the difference between your sample mean and the population mean, X bar minus mu. So my X bar is 24. If I subtract the population mean of 22.5, I get a sampling error of 1.5. So that's the difference between my estimate and the true population mean. I was off by 1.5 years. That's my sampling error. And you should have done the same. Now let's do this again. Part C, estimate the population mean by taking another random sample of 3 students of your choice. What is the sampling error? So we're going to do the same thing, but I want you to pick 3 different values for your sample this time. So pause, pick 3 different values, calculate the sample mean, and then calculate your sampling error. So this time I chose 19, 19, and 23 from the population above. So this is my sample of size 3. If I calculate X bar by adding up those 3 values and dividing by 3, I get 20.3. So now I could calculate my sampling error, which is going to be X bar minus mu. So in this case, my X bar was 20.3. And then I have to subtract 22.5 because that was mu. And I get negative 2.2 as my sampling error. And if you picked a different sample, you probably got a different X bar and you had a different sampling error. But the point is, every time we sample and we look at the sample mean, most likely it's going to be different from the true population mean. And sampling error could be positive or negative. Sampling error is going to be positive if your sample mean is greater than the population mean. And like in part C, you see how my sampling error was negative? That's because my sample mean was less than the true population mean. So to sum up, kind of the point of this first introductory lesson is that sampling error is inevitable because we're using a chosen number of data values which are randomly selected by chance from the population. And in practice, we will select only 1 sample from the population to estimate the mean of a population. And a population can only have 1 mean, yet depending on what sample you select from the population, the mean of a sample is going to vary from sample to sample, as different samples of the same size are randomly selected from the same population. So we could think of the sample mean X bar as a random variable because it all depends on the particular data values which are randomly selected from the population.